So I'm going to start with Conptt. And like I told you, I'm going to break it up by section. This is Tucker, since I've been talking about him. He's really tired right now, so it's not going to be super exciting. He's real cute. That was Obi. He ran off already because he's antisocial. So I don't waste your time. So talking about Conptt, I'm going to look off to the side just so that I can keep track of what I'm doing. We talked about scientific thinking. Basically, all it boils down to is that unless we can actually look at something, study it, perform it as an experiment, and then repeat that so that we can analyze data, it's not technically science. There's plenty of things that are logical thinking, but it doesn't mean that it's 100% science or that we can call it a theory or anything like that. So what we use to test it to decide if a natural phenomenon that happens in the world is science or not is Conptt. So it's spelled CONPTT. It stands for consistent, observable, natural, predictable, testable, and tentative. So just going into each one of those, basically, when you're looking at a certain topic, you have to consistently look at that same one. You can't change something about the experiment from trial to trial, because then you're not looking at the same results truly to compare them. So one of the examples I used in class was talking about chromosomes. We used to think that there was 48, now there's 46. They always were testing the number of chromosomes, not the type, or if there was a mutation or anything like that. They were just testing how many do we actually have. That's talking about consistency, and that goes along with predictability as well. Now, talking about observability, these are limiting you to your 5 human senses. So if you can't see, touch, smell, hear, or experience it in some way, then it's not technically science. So this is talking about like with unnatural phenomena. So we're talking about like alien existence and things like that. Yes, there could be a lot of logical reasoning for it, but unless you can actually see, observe it, write it down, and compare it again to other people's notes, we can't really call it science. And I know that all this is really straightforward, but just as a review, it's nice to have it. Now, everything does have to be natural events. This doesn't mean that we can't influence an experiment to happen. So what I mean by that is that it's natural phenomenon. We can't decide something's going to happen or alter the way it happens to consider it science. Now, we can set up experiments that we can predict what will happen in them. That's totally fine, but we can't actually change anything about it. It also has to be things that just naturally happen. So the example I gave in class is things with like Moses parting the Red Seas. That may have happened. There's record of it, but we haven't ever seen it happen again. It's not a natural event that happens often, so it's a really hard time saying this one time it happened, the one time it was recorded, and now it's scientific fact. So it's more of just one of those things that it has to be something that we can actually understand and potentially see again. Now, predictability, again, this goes along with consistency. When you set up an experiment, you form a hypothesis about it. You almost always know what you expect the outcome to be. You may not be right, and that's fine, but you have some sort of expectation because basically you can kind of figure out what's going to go down. So when we did our experiment in class, we figured music would increase our heart rates. That was a prediction that we're making because we know music motivates us and we like to listen to music when we work out. And we used all these outside things that may be opinion-based, but we could kind of predict what was going on. The same thing with that is that we have to have some sort of consistency with it as well. If we can't have a consistent experiment, we also can't predict what's going to go on with it either. And the last couple, it has to be testable as well. I think this kind of goes hand in hand with observability. Unless you can actually test it out and put it in an experiment form, we can't consider it science either. We can't just decide something's science because it happens once. We have to be able to test it, compare data, analyze our data, and then form conclusions from that. And our last one, you have to know that everything is tentative. It's always subject to change. There's tons of stuff. I mean, we know, we just got done talking about cancer. There's tons of stuff that right now we know is true, but if we have some sort of medical advance later on in the future, those things can change. It doesn't mean it's not science. So you have to know that with something that's scientific, it's always subject to change. Even theories that have been around forever, we always just have to assume that we're humans and we don't know everything, and we might make new discoveries. And then looking at experimentation, it just kind of pulls all this together. To be honest, your test, there's like 6 questions on it and you'll be fine. If you have questions about anything in any of these review videos, and I'll say this again in the other ones in case you don't watch this one, email me. I will be on my computer pretty much all the time for the next 3 or 4 days, and we're reviewing in class and all that, so we'll go over all of this. But hopefully this video doesn't totally suck. It's really weird to talk to you guys on it. So I'll see you in the next one.